Hello, everyone, and thank you for joining us today for a session on digital transformation on the shop floor. My name is Anthony Rodriguez. I'm the Vice President of KETIV, and I'm joined by Greg Pfeiffer, who leads our manufacturing practice service business. Welcome, and thanks for joining us today, Greg.
Well, thanks for having me, Anthony. Appreciate it.
Everyone, this is our third session in this digital transformation topic that we began a few months ago. And just to recap, we had two sessions prior to this, the first being on how product data should be integrated into the rest of the business and the opportunity that provides in transforming your business and delighting your customers. The second was looking at both tasks that could be automated in your engineering process, as well as processes between departments that could be automated, and how that automation could drive new insight, gather more data that helps you define your product in the future and better connect with your customers. And today, we're going to look at the make side of the business and how manufacturing is shifting and how there's opportunity for all of us to really rethink how we take products to market and how we get those through the shop in a way that really this all about delighting our customer. And that's what we do here at KETIV. Our role is to help you automate the development and design of your product, both how you sell your product, how you engineer, how you make it, ultimately connecting that information to the rest of the business and your customers. And in the end, the goal is to make a more delightful experience for your customers and meet their demand. I've been in this business and know many of you who I see joining here. So again, thanks again for joining, and been in this business for a good 15, 20 years. And we've helped our customers shift from a more manual process to digitizing information. We're now seeing customers begin to take that digitized information and use it to do what they've always done faster, better, in new ways. And by doing that, you'll get more insight. And now the conversation is, how can I use this information to transform the business going forward? And I'm really happy, like I said, to have Greg joining us. Greg's one of the newest members of our team. He comes from the manufacturing industry. And before I jump in, Greg, why don't you tell us a little more about yourself, and we'll go ahead and get started.
Yeah, my name's Greg Pfeiffer. Like Anthony said, I'm the manufacturing practice lead here. KETIV brought me in to help really add a little more maturity to the manufacturing offerings here. So that's what I'm hopefully going to be able to do for the organization. I've got quite a bit of manufacturing experience. I spent a number of years in direct manufacturing with several aerospace manufacturers. So I was a manufacturing engineer and ANSI programmer there. And following that, I spent, over 10 years working in the CAD/CAM industry itself, specializing on the CAM side of things. So I think I bring some experience to help build out the offerings that we have here at KETIV.
Great. Thanks, Greg. So with that said, we're going to go ahead and jump into the presentation. The last thing I'll mention is if anyone joining has questions, feel free to use the chat. We'll be monitoring those questions as they come in, and be sure to answer all the questions at the end of this session here. So let's go ahead and jump in, Greg. First, I want to really explain why this is important and why this is coming up today. And if you really think about things and look at traditionally manufacturers have looked at a few different ways to differentiate and separate themselves. Productivity has obviously been one way that our customers and manufacturers have looked to drive improvement in their business. And really, we see three categories like this. There's productivity, there's differentiation, and the process you use to actually build your product. And manufacturers are seeking to increase productivity by really addressing two sides of that productivity coin. There's the input side and the output side. And on the input side, you can do things like lower production costs by reducing overhead, cheaper materials, reducing labor costs. And on the output side, there's a lot of new trends happening around automation, robotics, different process improvements, lean manufacturing. So there's a variety of things you can both do to increase productivity from input and output. And while these changes have been effective and helped our customers improve their business, they're not long lasting. Eventually competitors find out how you're doing things and catch up, and you're constantly having to reinvent how to become more productive. The second is around innovation. All customers we talk to are looking for that next great idea, looking to enhance their product, to differentiate themselves in the market. These are just a handful of examples that some of us may be familiar with. But really, again, this gives you a time-based differentiator in that your product is different, but competitors tend to catch up, and we're always thinking about how do we continue to innovate? How do we continue to separate ourselves as we go forward? And then the last is around process. Customers are looking at new methods and processes that, again, give them a competitive edge. And this is also a difficult differentiator to maintain, because process at first that are unique and highly advantageous quickly become the norm in the industry. And we're seeing that in a variety of ways today. All three of these examples we talked about, our customers are constantly looking for new ways to improve them. And, we're always playing catch up, and competitors are always playing catch up. So now it's time to think about, with the new trends, new technology available, how can I really rethink my business to separate myself and meet the customer demands that are coming up? And so let's talk about some of those trends that we're running into. The three trends we see really revolve around production, how you actually make your product. And that's why we're here today. There's a variety of new ways to make your product, or a variety of new ways to connect both engineering and manufacturing and have them work together rather than a handoff of information. Every customer we're all dealing with, and I'm confident we all see this, our customers' demands are changing. They want things now. They want to be able to configure. They want to customize products, and they don't want that to change the delivery times. And we're having to adapt to that. And then products are becoming more complex to meet these challenges. And so when we look at all of these trends and the customer expectations, we need to now begin to think about the technology that's available, the infrastructure we have, and how we can embrace some of this to really meet the demands and the trends in the industry. And the first, like I mentioned, are the means of production are changing. All of you are familiar with this to some extent, whether it's around additive manufacturing, whether it's around metal printing, which exists today. Some of us have begun using some of the generative design tools to embrace some of those new manufacturing techniques. But the bottom line is production is changing. You think of automation in the shop and robotics and having a more versatile work environment for your employees in that shop. We have to be able to rethink how we're doing this and use technology to embrace it. And Greg, I know you've, with the experience you've had a variety of experiences that have seen how production's changing and how this may have helped you in the past. You want to share an example?
Yeah. When I was looking at these slides, one situation that, at an organization I worked at just popped up in the front of my mind immediately, and that was about 20 years ago. It seems like a long time now, but it really wasn't that long ago. I went to work for a little startup company, and this startup company had a product that we were trying to bring to market, and that product was an entertainment device. And when you think about it, in today's terms, it was a lot like what an iPad is today. It was, or a tablet, but it was early. It was like, the iPad came out in 2010, right? So it hasn't been around all that long, really, 11 years now. And but a good 10 years before that, we had an idea for this product. Like I said, it was an entertainment product. Really, what it was a custom set of electronics, a motherboard, a battery, an LCD panel, a D-pad for up, down, left, right, those kind of things, and a joystick, right? And this entertainment device, it was aimed at going into restaurants and bars, right? And really, we were the financial model was to put these in bars and restaurants, allow people to play for free, and then we were going to charge money based on advertising. And we had a lot of advertisers signed up. We had restaurants and bars signed up, and it was up to us to to build and deliver this product. And so we had a team that developed the electronics, really good set of electronics, things way ahead of the time. So we developed wireless communications before Wi-Fi was even a standard, those kind of things, right? So, and then what we had to do was we had to take all these high-end electronics that we were developing, and then putting them into a plastic enclosure that we could then use to deliver to the different venues. And in those days, you didn't have the kind of manufacturing processes that you have today, like the additive models or the additive processes. So what we ended up having to do at the time was to do injected molded plastic parts, right? And when you think about the way that fits into a new product design cycle, really what we ended up doing was we ended up designing all the internal components first, designing the shell around it, and then taking that shell and having that produced for us. We didn't have our own manufacturing capabilities, so we were farming it out. And in that process took quite a bit of time and quite a bit of money. We had to have the product, it's the shell itself designed, and then the tools designed, and the tools produced, and then molded products, right? And in my opinion, it wasn't really the best way to approach a product design, but it was really an iterative product design, but it was really the only thing that we had available to us at the time. And so we went through this process. We got an initial shell developed, an initial housing for this device. And the first thing that we did was we tried to assemble all the components into it. And what we found was that, there was a fit issue. We had an interference with apparently one of the electronic components on this motherboard, this custom motherboard that we had, was a bit taller than we had anticipated. So we ended up having an interference designed in, right? So how do you deal with that? It's you can go back and remake, modify the tooling and do another run in the injection molding, or you can do secondary operations and basically trim the rib on the inside of the housing. That's what we ended up doing early on, just because we were trying to get through, multiple iterations of this design just to make sure that everything worked, right? So we did some, secondary ops to the housing, and then we were able actually to go and assemble products, get products in the field, and so on. And then you start running into other issues. Like one thing we didn't anticipate was that the amount of heat that would build up when the devices were charging. So when these things went in the charging stand, they would overheat. So we realized, well, we need more ventilation slots cut into this part or added to the housing. So there were several iterations like this that we had to go through. And in those days, it was either do secondary operations on the parts themselves, or go in and modify the tooling and mold some more parts. If we were doing this today, we would have approached it much differently. We would have almost certainly used additive, especially in the early stages of going through the design iterations. We would have probably 3D printed the initial housings. When we ran into the fit issue, we would have just made a model change. We would have printed more and kept right on going, right? When we ran into the heat issues, we would have made some new models with some new heat holes or heat vents added, and then we could have had several different options available for us to do our testing with, and we could have gotten quickly to a model that would have been good and robust and last for a long time. Well, yeah. Ultimately, what ended up happening is the product was unsuccessful. I think it was largely unsuccessful because we really couldn't go through the number of design iterations that we needed to go through to get to that point where we had a good, robust product that was producible for a reasonable cost, right? So eventually it failed. But I think if we had today's means of production available for us, I think it likely could have been a different story, and it could have been very successful.
Yeah, I really like that story, Greg, because as we work with customers, we tend to think about the trade-off costs of producing a part the way we've traditionally created it, whether it's additive or whatever the production method is, versus how to produce it in another way. But we really don't tend to think about the costs of the whole life cycle of the product. And what you're talking about is, while the initial cost to print today may have even been more expensive than what you did, as you look at how that product evolved through the changes, the iterations, the customer requests, the overheating issues, and you add all of that up, the flexibility and versatility would have given you a lot more ability to get that product to market quicker, respond to the changes, and likely be more cost effective going forward. So thanks for sharing that. Anything else you want to add before we move on, Greg?
Not on that particular one, no.
Yeah. Good. So we're all familiar with this in some way, somehow. Greg shared one example around, how additive would have helped in one of his previous experiences. The next area, we're all experiencing is our products are becoming more intelligent, which increases the complexity of the product, increases, the risk in bringing a product to market. As you have more electronics, you have more devices, more parts, components built into this. But it's a necessity. We need to meet customer demands who are natively connected. They're natively digital. They want to work that way. That's an expectation they have. And Greg, you had another story you wanted to share as you saw this this part of the presentation as well. Go ahead.
Yeah, it's interesting when I first started, getting more familiar with digital transformation. One of the concepts that they talk about often is this concept of a digital twin. And initially, when I was thinking about a digital twin, I'm a very CAD-centric person. I thought, oh well, the 3D model, that's my digital twin. But actually, the more I started thinking about it, the more I started investigating, there's quite a bit more to it than that, right? The digital the 3D model is certainly a part of that, but for these complex, these intelligent products, there can be a lot more to it. It can be basically any kind of digital information that will describe the exact state of a given instance of a product, not the product itself, but maybe one instance of a product. So for example, recently I've been working in an industry where we provided communication capabilities to a lot of different types of consumers, manufacturing being one of them. And I got a call from one of my colleagues in that industry, and he was telling me about a situation that he was dealing with where he was designing the communication capabilities for a large automobile manufacturer. And the communication capabilities in this particular area were on in the assembly area, right, where they were basically putting parts together. And when I started chatting with him about what the requirements were, I was anticipating things like, well, there are going to be the tools that they need when they're working on assembling the cars, and those are going to be smart. They're going to be talking to the back-end systems and so on. And that was part of it. But the thing that actually opened my eyes a little bit was the cars themselves were actually needing to communicate with the back-end system. So what was happening was, early on in the manufacturing or the assembly cycle, as soon as the car itself had some power and some components were installed, the car would start communicating with back-end systems. And when things like that component was installed, diagnostics would be run, and the state of that would then be reported into the back-end systems. And that when you think about it, that's really the digital. You're really assembling a digital twin for an individual instance of that product. An individual car. What's the exact state of that car at this time? And it starts early on in production, right? And it made me think about how manufacturing needs to have infrastructure built to be able to deal with these smart devices and communicate with these smart devices even early on during the manufacturing cycle itself. So it's a change in the manufacturing process as well. And then you see that information about the cars maintained throughout the life of the automobile, like what's the version of the firmware that's there now, and does it need to be updated and so on. It's funny. Yesterday I saw a big recall of Teslas in China, 280,000 recalls. And I said, man, that sounds like it's going to be a nightmare, right? And then I went in and I looked at it, and really what it is, oh, they just need to update the firmware. It was, drive assist was turning on a little easier than they wanted. So it's as simple as just pushing out a piece of firmware. So it's not at all what you would think of as a normal recall, right? It's just all over the air. It's pretty interesting.
Yeah, no, that's a great story, Greg. And issues like that, which traditionally in the past may end a business, may put down a business today, when thought out right and building the kind of connectivity we need going forward. Not only does it not shut down the business, but it actually provides more value to the customer, and that customer experience is much better, and it's what keeps them engaged with you. So appreciate you sharing that. And I'm sure all of us have examples to talk about, and happy to hear any of you if you want to reach out to us after and discuss this in more detail. And then all of our customer demands are changing. I mean, just in this last year, the way Amazon's grown and delivered to all of us, the expectations that they set and the bar they set are driving our customers to really want to see the same from us. And how do we respond to that? How do we go ahead and meet the demands that customers have? And we'll begin to talk about that as we go forward also. Now, when we think about our customers, and I'm going to probably overly simplify some of this, but most of our customers have a manufacturing process that they're going through. And, every process starts with some sort of concept, whether that concept's created internally, whether it's ideas coming from your customers, your vendors. There's a concept that begins. And from that concept, you then have the ability to design your product. You ultimately make your product. Someone needs to sell the product, whether it's internally you're selling or through a distribution network. And then that product operates and retires. And when we look at the traditional product development process, we tend to feel that, the only way to improve the profitability and improve how your business runs is all the inputs you see throughout that phase. So whether it's concept, designing, producing, can I do what I do today faster? And eventually, again, we get back to, while you may differentiate temporarily, competitors tend to catch up, learn how you're doing things, and there's this constant race of trying to innovate both the process and the product. And you end up with this fixed product value. You sell the product for an amount, and you're trying to drive down the cost or the speed of getting that product to market. And KETIV, Autodesk, and ANSYS, as we look at putting our technology stack and how we help customers go forward together, we tend to think that we can layer on value at each stage of the process. And we're seeing this pay off for many of our customers today. From a concept standpoint, our customers want to have influence into that. They want to be able to personalize their product. They want to interact with that product. They want to get their hands digitally on that product to see how it's going to work and ensure what they're buying is accurate. From a design standpoint, this last year, if anything, taught us that, the agility our teams need to work together is not going to decrease. It's going to continue to increase. And whether it's internal teams, customers, suppliers, we need the ability to do that in a collaborative way without disrupting how we go to how we run our process today. And giving you the ability to collaborate effectively without that disruption is key for us as we go forward. From a production standpoint, we are going to be and are the leader in providing new ways of making your parts. And we'll take a look at some of what we're doing in a little bit. But you need that flexibility. You need the ability to create parts in different ways and integrate not just how the parts are made in manufacturing, but how the parts are made while you're engineering and designing your product, and converging both design and manufacturing and making that a single process and something that is collaborative will be important. Ultimately, again, it's about the customer experience and giving your customer choice, giving your customer the ability to customize what they're looking for. We see continuing to grow, and then the connecting of your product. And so connecting, to Greg's point, means two things. It means as your product's developed, is that production information connected to engineering and the rest of business? And when your product reaches your customers or your installers, is that product still connected to your business. So you can learn how that product's functioning in the field. You can take information from the field and use it to drive new product improvement going forward. And ultimately, potentially change your revenue stream as you go forward. You see, as you go through this process and you begin to build in each of these areas and ultimately connect with your product in the field, we believe that going forward, we're going to see many manufacturers change from being a business where your revenue comes from selling a product to having your product be a service, much like software has gone through in the past. And there's many examples of this already today. Rolls-Royce is a good example, who used to make and sell jet engines, and today they just sell airtime. So if they're powering a plane in the air, they bill that airline based on how much time they're using their engine. That wouldn't be possible if they weren't connected to that engine and didn't have the ability to always make that engine up and running, optimize it, much like Greg's story with Tesla, to ensure that that a plane or an engine wasn't down. Because when something's down, Rolls-Royce isn't driving any revenue. They're only creating revenue when that engine is flying. And again, that may seem extreme for many of us today, but we're seeing that happen in a variety of industries, and shifting and rethinking from being a product company to really shifting my product to become a service for my customers. And I think as you think about that, you'll see opportunities for each of us that are here. And that gives us the ability to create and make this product information an investment and increase that value of that information over time to continue to meet the customer expectations that you have. And that's really what we see as a future of making things. And that future is today. Like I mentioned, we're already seeing customers begin to embrace that and shift their business model as they look forward today. And then, you need to ask yourself, why KETIV and Autodesk? And I believe you'll quickly see, if you haven't already, that the tools we're giving you and the ability to integrate those tools to work with one another, both from engineering, how you sell your product, through making your product and connecting it to the field, is going to give you the ability to get data that will allow you to create better, faster, and more informed decisions as you develop those products. Autodesk, and we make no bones, no mistake that we will be the leader in materials and how those materials are fabricated going forward. And I'll share some examples with you in a bit. And then the third is, this digital and physical convergence, like Greg mentioned. A digital twin is a big concept out there. And how do you take this 3D information you built, this digitized information, and begin to use that to continue to build value for you? Having that digital twin out there so that you can continue to leverage the investment you have in all parts of your business, and your customers can build on it, will be important. And then, there's cloud, mobile, social, that's always changing. And the infrastructure you have, there's many more flexible options that exist. And all of these things need to be thought through together so that you can look at how to improve your business going forward. Now, many of you in this session I'm familiar with you. We've worked together for many years. Some of you are new. But many of you have the Autodesk collection, the manufacturing collection. And I'm going to share a video just to share with you some of the workflows that you already have access to today. Some of this you have access to, some of this you can begin to enable with small investments. But again, much of what you'll see here, if you're in the collection, have access to begin using. And I highly encourage you to begin experimenting how Inventor and Fusion can work together, as an example, how your design and manufacturing information can come together in a single process, and your teams can begin to work together. So I'm going to play this video, take a look. It will begin to expose you, open to your eyes to what KETIV, Autodesk, Ansys are beginning to do, and how this is providing opportunity to all of you as customers.
When designing the component parts of assemblies, engineers frequently face product development demands that often lead them to rethink how parts might need to be designed and manufactured. Traditionally, an assembly component might be manufactured through molding, casting, or maybe via a process of machining from billet to achieve the desired shape. But what if the requirement was for the same mechanical function and equivalent mounting size, but with a reduction in component weight or consolidation of assembled parts? Even the most capable of design engineers will be limited in the number of possible design iterations they can produce in a given time. Generative design changes this. Combining artificial intelligence with cloud-based computing, generative design uses goals and parameters such as materials, loads, manufacturing methods, and cost constraints to design your parts. Unlike topology optimization, generative design explores hundreds or even thousands of possible permutations of a solution, testing and learning from each iteration what works and what doesn't. Successful design alternatives are quickly presented where the ideal optimized design, which caters for the desired method of production, such as 2D machining or 3D metal additive printing, and can be chosen and sent out to be manufactured. If the critical requirement is to reach the minimal weight of a component, for example, to reduce the energy required to rotate a mechanism, then 3D metal additive printing might be the best solution. Additive manufacturing can be used to produce parts that would be difficult to manufacture conventionally, with the option to replace solid structures with strong, lightweight, hollow components containing internal latticing. The additive build can be simulated to predict any issues before models are sliced with the 2D toolpaths necessary to control a laser to print the part. Printed parts can then be quickly and easily machined for accurate final finishing. In this example, you saw Autodesk Inventor for the CAD design and assembly modeling, and Autodesk Fusion 360 for the cloud-based generative design. Autodesk NetFab for the additive print simulation and manufacture, and Autodesk PowerMill for the toolpath creation and machining. So whether you're looking for additive or subtractive processes, or a hybrid of the two, standardizing on Autodesk technology will help you to make anything.
So that's one example. And again, many of the tools you saw there, the Fusion and Inventor part, many of you that are on this call have access to today. And I highly encourage you to reach out to us, begin to talk to our team, understand what's available, how you can begin to embrace some of these technologies to improve your development process going forward. And again, really, it's about three things that we're investing in. Is we want to help you make better, faster decision making by embracing the technology and utilizing the implementation expertise that we have available today, like Greg and his team offer from a manufacturing and production standpoint. We want you to embrace the new fabrication techniques and embrace what Autodesk and Ansys are both investing in to help you use this as a competitive advantage for you and your company. And this digital and physical convergence, you will see and begin to see how that can powerfully help you change not just the development of your product, but the experience your customers have with you, and open up your eyes to potentially new revenue streams that you and your business will benefit from. The cloud and mobile and social aspects of this, again, are benefits that will continue to grow. Like I mentioned, through this last year, the one thing we all learned is that the ability to work in an agile environment and connect with people in real time and have multiple both customers, vendors potentially, and our employees that may be around the world today working out of home or other remote offices will continue to increase. And having that collaboration drives new ideas, drives innovation, and allows us to create a product that everyone's proud of. And at KETIV, our goal is really just that. Our goal and our vision and where we're helping customers is to help you automate that product development process and how you get it to customers, connect the information you gather to other business systems, and ultimately delight your customers. And we help customers in all parts of their process. We start with understanding how your customer buys today. We understand how your sales team sells the product today, whether it's through distributors or your internal sales force. We want to understand how you engineer, how you make decisions in engineering and come up with new ideas, and ultimately how you get those ideas to your customer. And as we begin to talk to customers, we begin to share with them how they can automate tasks in each department, but more importantly, how we can automate tasks between departments. So if your customer wants the choices to be able to configure and connect that product, KETIV offers multiple ways of automating through a configure, price, quote option. From an engineering standpoint, you want to be able to connect with how your sellers are selling and be able to respond to proposals and quotes that come up, so that engineering time isn't used on invested in areas that may never go anywhere. You also want to begin to take away tasks that no one wants to do and getting production information to the shop so you can ultimately deliver your product on time. We find that there's a lot of ways to automate that information flow between both engineering, manufacturing, and how your product's delivered. Ultimately, all of these processes are going to allow you to capture data, capture analytics that can be shared with a variety of business systems. And that's the last area that we help with, is automating the product development process, connecting it to the rest of your business, and ultimately delighting your customer. And so when we think about what's next for us, we encourage you to do really two things as we go forward. First off, all of your engineers, designers, manufacturers should be connected to our Fusion Friday presentations. The Fusion Friday presentations we have don't cost anything. It's a service we provide to our customers. You can log in through this link here and register. And what this will give you the ability to do is stay in tune with where we're headed and what tools are available and how to use those tools in a manufacturing environment, whether it's around the CAM process, whether it's around additive, whether it's around factory and how you optimize your factory flow and how parts flow through to meet customer demands. By registering, you'll begin to learn the tools that are available in the collection and how to apply those to your business. And from a management standpoint, I highly encourage you to think through really one of two things. If you'd like to just get a fresh insight into us understanding one of the processes you have in your business today, sharing with you where you may be able to save time and add value by using the technology or the implementation expertise we have, we'd definitely be happy to spend a couple of hours to assess and come up with ideas together, or select a transformative project that you have in your business coming up. And we can work together to think about how we can apply this new technology that's available to you to rethink how you go to market with that product. Everyone's met Greg Pfeiffer here today. I highly encourage you to reach out to him to schedule either of these two opportunities, or to just chat and get to know Greg more and talk about his experience and where you're headed as a business. So with that, Greg, I know you're new. You're new with our company. We're excited to have you as you're building out your team. I hope you hear from many of the customers here today. But I think it's also important, Greg, for you to share with the participants why you joined KETIV and why you wanted to get back in this industry at this time.
Yeah. So yeah, thanks, Anthony. Yeah, as I described earlier on, I had quite a bit of manufacturing experience. It was mostly earlier in my career. For the past, quite a few years, I've been working on some other technologies that have been, helping customers deploy and so on. But I've always been fond of the manufacturing industry. It's probably what I enjoyed the most out of anything that I've ever done in my career. And so for the last several months, I've been really thinking about, well, if I could focus back into the manufacturing industry, where would I want to do it? And I'd want to do it in an organization that's focusing on that convergence between design and manufacturing and CAE and so on. And I think KETIV is an organization that definitely does that. And and the Autodesk products offer those capabilities as well. So I think for me personally, this is a good spot to be. So that's why why I've come back in.
Great, Greg. Well, we're looking forward to see how you build out that team and how you ultimately help our customers make their products better. And with that said, again, our focus at KETIV is to automate how you engineer and build your product. Connect that with the rest of your business to drive insight into making better decisions in all parts of the business, and ultimately delight your customer. And that's really what digital transformation is all about, is making that experience better, making your business more profitable. And we look forward to learning more about each of you as we go forward. I want to thank everybody for joining today. I am going to take some time. We have a couple of questions that we'll address here, and then we'll wrap it up. And so the first question really has to do with I mentioned the factory part of the business and what tools are available. The question is, what tools are available to document how my material flows through the organization today? And many of you, just to answer that and broaden the question a little bit, many of you, going back to what I said, have the manufacturing collection. And if you don't, again, reach out. We can share what that actually is and what that means and how it can help your business. But this manufacturing collection is called a collection in that it includes tools that cover all parts of the product development process, including a factory layout tool. And the factory layout tool in the collection gives you the ability to not just lay out the factory and the equipment necessary, but also look at how to optimize material flow within the organization. You can begin to simulate that, monitor it, and use that information to continuously improve how things are going forward. So that was one question. And again, if I didn't cover it completely, feel free to reach out to me, Greg. We'd be happy to talk more or share with you what that looks like. It looks like that was the only question we had now, Greg. So I'm going to go ahead and wrap up the session. All of you know how to reach us. Again, Gregory Pfeiffer at KETIV.com. My email is Anthony@KETIV.com. Feel free to reach out to me anytime. Again, thank you for joining us. We look forward to learning more about your business and encourage you to reach out. I'll see you all soon. Take care.